If you recall from introductory calculus, the definition of the derivative had to do with the rate of change of a function at a specified point. But as we move into functions of multiple variables, this becomes more complicated because we now aren't just changing with respect to x, we might be changing with respect to y as well. So if we take a look at this diagram here, we have some sort of surface f, and that's the purple here, and we have some point. And if we notice, if we don't change at all in the x direction, we're just worried about change in the y direction, then it looks like the surface is changing, it's kind of sloping upward. But if we instead fix the y point and look at only the change in that x direction, so if we look at the change in this direction, it kind of looks like it's sloping down. So there's a problem here. Now when we think about derivatives, we can't think of a single derivative in terms of the function that we're dealing with. We have to think about multiple types of derivatives. In this particular case, we're going to be discussing the idea of a partial derivative. And what a partial derivative means is you take one of the variables and you take its derivative in that direction and you fix all the other ones. So for practical purposes, all of the other variables are treated as constants when you take a partial derivative. So if I have some sort of function here, which is, a function of two variables, then assuming that, it's differentiable, that limit exists, all the typical things that we have to worry about when we think about what a derivative is. Notice this is kind of a little curly d. This is a little curly dz dx, or we might think of it as a partial f with respect to x. Or we might write f with a small little x, xy, and then similarly, if you do the same thing, partial of z with respect to y, and that's how it's said, equals the partial of f with respect to y, equals fy of xy. These are called the partial derivatives. And there's also this notation, which is the same notation with the bar and sum ab, and that just means you take the partial derivative and you plug in the values at those points. And specifically, if I have a function of three variables, I can define a partial of w with respect to x, partial of w with respect to y, partial of w with respect to z. And partial derivatives are probably it's one of those that students usually either get immediately or they have a little bit of trouble and they get over the hump. But they're actually a fairly straightforward process, and we're going to do some examples to try to figure out how to approach partial derivatives.